My name is Jim Ang. I'm at Sandia National Labs, and I manage our Scalable Computer Architectures department. So we're very pleased to have Arthur, which is our Intel Mic Architecture cluster. Of course, many people know we accepted it last year in September, just before supercomputing. In the intervening time, we've been using it to collect application performance data on our proxy applications. We've been exploring a number of different programming model implementations for those applications. We've also been just very recently, starting to use the testbed as an experimental platform to create validation data for a separate set of architectural simulations where we're trying to model the Knights Ferry coprocessor with our architectural simulators. And then finally, the last area of activity is for system software development. So Sandia has a long history of work in lightweight kernel system software, and we're trying to port our open source lightweight kernel called Kitten to Knights Ferry card. And the reason we would want to do that is because Kitten has very good support for the memory subsystem access that's better suited for high performance computing. Things like support for large page tables and the ability to address memory as contiguous blocks of memory. The role for an early testbed, and I'll be honest, for my organization, I'm on the research side. If we're talking about mic as a product, we're probably less interested. We're more interested in having early access to technology when it's still experimental. And the reason for that is we're trying to understand what the state of the art is for new many-core technologies. And that's also why we're trying to compare our testbed results with our architectural simulator results. Because the next step then is to make projections on new capabilities that don't exist today, to perhaps give feedback to Intel and APRO on the design trade-offs that could be made for the next generation. To date, probably our most significant accomplishment is the experience we've learned in developing a common code base for some of our proxy applications that take advantage of Intel Intrinsic's support for vector operations. And these then are examples of our application codes that can run, where we can run the same source code on Xeon CPU processors or the mic coprocessors. And that's been a very good experience. We've been finding good performance in both cases. The experience working with Intel and APRO has been very good. It's again, because we're not asking for something out of a product catalog, right? We're asking for really a first of a kind machine. I think it's really I'm very pleased that we had the foresight from the outset to establish an MOU, to a memorandum of understanding, and to write our non-disclosure agreement to cover not just Knights Ferry, but also looking ahead to Knights Corner, plan our procurement contract with APRO to allow for the phases to support upgrades, and I think the interaction with APRO and understanding what the design trade-offs are has been very good. So the other thing I would say is that this experimental architecture testbed is a key enabling capability for co-design. And it's part of a set of capabilities that we all really need to have. In addition to the architectural test bed, we need to have architectural, I'm sorry, it should be experimental test bed. We have to have architectural simulators. We need to have a set of proxy applications that are easily modified to incorporate architecture-centric capabilities. And then finally, we need to have a set of proxy architectures, models of the experimental architecture test bed that we can then use with our simulator. So in a sense, there's a feedback loop that, and there are many loops, right, that go between our experimental architecture test bed, our architectural simulators, and then both our proxy applications and our proxy architectures. So as we do design iterations among these different co-design elements, that we will understand and learn, make recommendations for the future for how new architectures should evolve. And ultimately, for my group, we're interested in influencing future hardware architectures. We're not just interested in trying to figure out what a new architecture is and how our codes need to change.